The local group is our cosmic neighborhood. It is a cluster of over 50 galaxies bound together by gravity. The local group's biggest members are our Milky Way, Andromeda, and Triangulum galaxies. These three dominate the group with their immense size and mass. The rest of the group consists of smaller dwarf galaxies. They might be small, but they play crucial roles in our understanding of the universe. For instance, they help us understand dark matter and galaxy formation. The local group is also part of a larger structure called the Virgo supercluster. The study of the local group provides valuable insights into galactic evolution. By studying them, we can learn about things like star formation and galaxy interactions. Understanding our place in the local group helps us understand the larger universe. Let's dive deeper into its fascinating members. The Milky Way is our home galaxy. It's a barred spiral galaxy with a diameter of about 100,000 light-years. The Milky Way contains billions of stars, including our Sun. Our solar system is located in one of its spiral arms, the Orion arm. The Milky Way has a central bulge surrounded by a disk of stars. It also has a halo of old stars and globular clusters. The galaxy rotates, with stars in the disk orbiting the center. The Milky Way's center hosts a supermassive black hole known as Sagittarius A*. It has several satellite dwarf galaxies, including the Small and Large Magellanic Clouds. These smaller galaxies interact with the Milky Way, influencing its structure and evolution. Exploring the Milky Way helps us understand our cosmic origins. The Milky Way is a key part of our local group, and it continues to be a focus of astronomical research. The Andromeda Galaxy, also known as M31, is our closest galactic neighbor. It is a spiral galaxy located about 2.537 million light-years from Earth. Andromeda is the largest galaxy in the local group. It has a diameter of about 220,000 light-years, more than twice that of the Milky Way. Andromeda contains an estimated 1 trillion stars, making it much more massive than the Milky Way. Like the Milky Way, Andromeda has a central bulge, a disk, and a halo of stars. Observations suggest that Andromeda is on a collision course with the Milky Way. Andromeda is a vital object of study for astronomers. Its proximity allows detailed observations that are not possible with more distant galaxies. Studying Andromeda helps us understand the future of our own galaxy. The Andromeda Galaxy is also surrounded by many dwarf galaxies. Understanding Andromeda is key to understanding the dynamics of the local group. The Triangulum Galaxy, or M33, is the third largest member of the local group. It is a spiral galaxy located about 3 million light-years from Earth. Triangulum has a diameter of about 60,000 light-years. While smaller than the Milky Way and Andromeda, it is still a significant galaxy. Triangulum contains about 40 billion stars. It has a well-defined spiral structure with prominent arms. Unlike the Milky Way and Andromeda, Triangulum lacks a large central bulge. This galaxy is also rich in gas and dust, making it a site of active star formation. The Triangulum Galaxy is an important target for astronomers. Its structure and composition offer clues about galaxy formation and evolution. Triangulum's proximity allows for detailed studies. It is a fascinating member of the local group, contributing to our understanding of the cosmos. Section 5. Dwarf Galaxies, an overview. Dwarf galaxies are small galaxies with fewer stars than larger galaxies. They are common in the local group, with over 40 known members. Dwarf galaxies come in various types, including dwarf spheroidal and dwarf irregular galaxies. They play a crucial role in our understanding of galactic formation and evolution. Dwarf galaxies often orbit larger galaxies like the Milky Way and Andromeda. These interactions can lead to tidal forces that shape the structure of dwarf galaxies. Some dwarf galaxies are being torn apart by these interactions. This process helps us understand the dynamics of galaxy interactions. Dwarf galaxies are also important for studying dark matter. They have high dark matter content relative to their luminous matter. Despite their small size, dwarf galaxies are rich in history. Section 6. The Sagittarius Dwarf Spheroidal Galaxy. The Sagittarius Dwarf Spheroidal Galaxy is one of the closest satellite galaxies to the Milky Way. It is located about 70,000 light-years from Earth. This dwarf galaxy is in the process of being disrupted by the Milky Way's gravity. It is elongated and stretched out in a process known as tidal stripping. Sagittarius contains a few billion stars. It has a low mass compared to larger galaxies. The galaxy is rich in old stars and has little gas. The interaction with the Milky Way is causing the Sagittarius dwarf to lose stars. The stars stripped from Sagittarius are being added to the Milky Way's halo. This process contributes to the growth and enrichment of our galaxy. Sagittarius is a fascinating example of galaxy interaction and evolution. Section 7. The Canis Major Dwarf Galaxy. The Canis Major Dwarf Galaxy is another satellite galaxy of the Milky Way. It is located about 25,000 light-years from Earth. This makes it the closest known satellite galaxy to our own. Canis Major is a dwarf irregular galaxy with a high concentration of old stars. Canis Major is in the process of being absorbed by the Milky Way. Its stars are being stripped away and added to the Milky Way's disk. This interaction is causing the Canis Major dwarf to lose its distinct shape. It is an excellent example of the dynamic processes that shape galaxies. The Canis Major dwarf galaxy has a complex structure. The galaxy's interaction with the Milky Way provides valuable data on the processes of galactic cannibalism. The Canis Major dwarf is a small but significant part of our galactic neighborhood. Section 8. The Small and Large Magellanic Clouds. The Small and Large Magellanic Clouds are two of the most prominent satellite galaxies of the Milky Way. They are irregular galaxies visible to the naked eye from the southern hemisphere. The Large Magellanic Cloud, or LMC, is located about 163,000 light-years from Earth. The Small Magellanic Cloud, or SMC, is about 200,000 light-years away. The LMC has a diameter of about 14,000 light-years, while the SMC is about 7,000 light-years across. Both galaxies are sites of active star formation. The LMC contains the Tarantula Nebula, one of the most active star-forming regions in the local group. These galaxies are rich in gas and dust, fueling the birth of new stars. The Magellanic Clouds are interacting with the Milky Way. They also exchange gas and stars with the Milky Way. The Magellanic Clouds are valuable targets for astronomers. Section 9. Collision Course Milky Way and Andromeda. The Milky Way and Andromeda galaxies are on a collision course. This event is expected to occur in about 4.5 billion years. The collision will be a slow and complex process, taking millions of years to complete. When they collide, the two galaxies will merge to form a new galaxy. This future collision is a subject of great interest to astronomers. It provides a unique opportunity to study the dynamics of galaxy mergers. The collision will trigger new waves of star formation. Gas and dust will be compressed, leading to the birth of new stars. The merged galaxy is expected to be an elliptical galaxy. The collision will also involve the smaller satellite galaxies. Understanding the Milky Way-Andromeda collision helps us learn about galaxy evolution. Section 10. Andromeda, the largest galaxy in the local group. Andromeda is the largest galaxy in the local group. It surpasses the Milky Way in size, mass, and star count. Andromeda's diameter is about 220,000 light-years, making it the most massive member of our galactic neighborhood. Its larger size and mass have significant implications for the local group's dynamics. Andromeda's size is due to its history of mergers and interactions. Over billions of years, it has absorbed smaller galaxies. These mergers have contributed to its growth and structure. Andromeda's large size also means it has a significant gravitational influence on its surroundings. The large mass of Andromeda affects the local group's dynamics. Its gravitational pull influences the orbits of nearby galaxies. Andromeda is a key object of study for understanding the universe's structure and evolution. Section 11. The significance of understanding our galactic neighborhood. Understanding the local group is crucial for several reasons. It provides insights into the dynamics of galaxy interactions and mergers. Studying our galactic neighborhood helps us learn about the processes that shape galaxies. These processes include star formation, dark matter behavior, and galactic evolution. The local group also serves as a laboratory for studying the universe. Its members are close enough for detailed observations. This proximity allows astronomers to test theories and models of galaxy formation. The local group's diversity of galaxies offers a wide range of study opportunities. Knowledge of the local group also has practical implications. It helps us understand the future of our own galaxy. Understanding our galactic neighborhood enriches our knowledge of the universe and our place within it.